Okay, there we go. Is that working?
Yes.
Perfect. I'll hand it over to Jamie.
All right. Well, last section of the day. Thanks very much for everyone's patience so far. We're going to be talking to you a little bit about OBS, which is our high-level mechanistic interpretability and activation engineering library we've built. It's called OBS because we're making transformers just so obvious, just OBS. Next slide, please. So in this project, there were two work streams going on. One work stream was looking at performance enhancements overall across the entire model. The idea would be that we're trying to see if we can make all of our interp work faster. To this end, we tried using a language called the Mojo programming language. And indeed, so I submitted a number of bug reports. We've got some performance testing through there. And I've kind of steered that team in the direction a little bit more towards looking at our use cases. I gave a talk at PyCon DE for that, but ultimately it wasn't ready in time for this project. The second work stream concerns the Patchscope library reimplementation that we've built. The OBS library is a powerful Python package that provides a set of tools and utilities for analyzing and interpreting language models with the Patchscope framework. It offers a range of functionalities to probe and understand the internal representations and behaviors of large language models at different layers and positions. With OBS, you can easily investigate how language models process and generate text, gain insights into their inner workings, and visualize the results using various techniques like heat maps and plots. So it's built for researchers, data scientists, and language model enthusiasts, and it empowers people to conduct interpretability experiments and reproduce standard results with ease. So we're going to be able to use this to resolve entities, estimate outputs, and decode attributes. We've re-implemented it and released it as a PyPI package, and we can share the link in the chat shortly afterwards where you can pip install this. Next slide, please. So the contents we'll be going through today, Shaheen will be walking you through what is a Patchscope, why is it useful, what have we built, some illustrative examples, and then I'll be closing off by talking about a library for the community and the next steps. Take it away, Shaheen.
Okay, so what is this this Patchscope thing that came out of Google Pear's lab? Well, we can begin by thinking of two separate forward passes. Now, the first step will be in the first forward pass to indeed pass a prompt through, but then at a given position and layer, extract the hidden state and have the option of applying some function to it and keep that to one side. And then for the second forward pass, constructing what is quite a clever target prompt, which is designed to extract certain information from the hidden representation which we're about to patch in. So you design this prompt, you pass it through a second forward pass, and then at a possibly different layer and position, you patch in the hidden representation from your first forward pass, and then you just complete the second forward pass and you generate some outputs, which are somewhat defined by this target prompt. And that's basically a Patchscope. So some notation just to define as we run through this presentation. I've spoken about the two forward passes. I'll often refer to them as the kind of source forward pass or model or prompt, and then the target forward pass, model, prompt, etc. So the notation kind of follows this as well. So you'll have a number of source tokens in the source prompt, target prompt. You'll have indeed S and T labeling different source prompt and target prompt. The models can also change within the same family. Yes, L and L star also defining the number of layers and so on. And we have the hidden representations also in the source prompt and in the source forward pass and the target forward pass separately. And then you are able to apply this function to the hidden representation in the source forward pass of the first forward pass here. While this is perhaps a lot of notation, a lot of jargon, this is the part that is of most importance. So the hidden representation in the paper is said to be entirely defined by four quantities: the source prompt, the source model, and a position and layer. And the Patchscope acting upon that hidden representation can be defined by four analogous quantities: a target prompt, a target model, a position, a layer, and then the option of applying a transformation to the hidden representation. So the patch scope, kind of taking a step back a bit now that we kind of hopefully know what it is interesting because it's said to encapsulate many mechanistic interpretability methods within its framework. So things such as the logic lens, tuned lens, future lens, some of you may be familiar with, and certain configurations of a patch scope can recover these techniques. And there's techniques that are recoverable across multiple tasks as well. So it's quite a nice kind of abstraction of many mech-interp methods. And this then also yields kind of improved solutions to some of the tasks, because you might have some configurations of patch scopes which hadn't been thought about before, and they actually the authors claim that they result in improved performance on certain tasks, such as attribute extraction and entity resolution.
So just jump in here for a second, if I may. In Ben's talk that we saw previously, he was training a linear probe to identify the objective based on a maze that they were working through. So it's entirely possible that you could use a patch scope to have a similar outcome to that tuned approach. And that would be a kind of an example of a tuned lens there.
Absolutely. So the paper discusses 5 tasks, and I'll try to run through some of them in some detail to show kind of why a patch scope might be useful. The first is of next token prediction. So you're trying to compare the final token predictions with the highest probability token per layer. And the authors build a logic lens with their patch scope framework, as well as a tuned lens, and they introduce this token identity method. And this kind of is quite a key idea, I think, in the Patchscopes work, which is constructing these very useful target prompts to extract the information that you'd like. So here it's just a kind of identity prompt where you have some random token mapping to itself, another token mapping to itself, and then you have a placeholder token here, which is patched, the hidden representation of which is patched over from the first forward pass. And basically, this figure is saying that this third method results in lower surprisal and higher precision, which is both good. Results in that, lower surprisal, higher precision than the tuned lens and the logic lens. So it's an improvement on the task. You can do the same thing for an attribute extraction task. In the interest of time, I won't go into this now. I won't go into it in too much detail. But you have kind of triplets of subjects, relations, and objects, and you want to recover the object given the subject, and you create a similar kind of target prompt, which is cleverly constructed, and the patch scope has better performance than a baseline of a logistic regression probe. And you can do the similar thing for an entity resolution task, which is trying to see how LLMs contextualize these entities in the early layers. And this is actually quite a fun plot in the paper, where they kind of show that as you pass through the layers with a patch scope with this target prompt, you can examine how the prompt Diana, Princess of Wales is kind of used or contextualized as you pass through the early layers. And they also mention that you could do cross-model patching, so using a model of the same family, but which is larger, to kind of explain a smaller model. And that's a 4th experiment in the paper, and it's possible. The same thing with multi-hop reasoning. They also construct some clever target prompts and data sets, and they show that patch scope can be used upon this task. But so then kind of in terms of talking about what we've built, this is our kind of API, if you will. So you can kind of import a patch scope source context and target context object, and then use a model with the backend being NNSite. You can pass your prompt, your layer, your position, same thing for the target context, pass them into a patch scope object, run it, and you can replicate something like this, which is a variation on the Rome, on the Eiffel Towers in Rome, I think it was, result. Now, in comparison to what the authors built, which was wonderful, perfectly functional scripted code, I ran it and I could replicate their experiments. It didn't quite enable researchers to generate a patch scope quickly and kind of get in there and play around with this abstraction. So that's what we tried to do. Oh, I think I've missed a slide there. And we tried to do it via well, we've built upon that Patchscope object by building a higher level class such as a logit lens, which is available as well in the library, as well as a token identity lens object, which is also available. And you can produce similar surprisal plots to that which you see in the paper, and a similar idea for the future lens. You can kind of construct a future lens, which is some work from David Bow's lab, via our Patchscope API, if you will, building up a source context, target context, then building a Patchscope. And with that, I'll pass over to Jamie.
I imagine we only have 30 seconds left. I'll be very, very brief here.
Yes, thanks.
Next steps here are to, as you can see on the screen here, to implement more of the paper and to implement more features. The key point here is that if we have particular users who want to do certain things, we're going to prioritize that use case. So do reach out to us and do let us know. Next slide, please. So yeah, to that end, we've got a library, it's on GitHub, we've got documentation, we've got a code of conduct, we've got community. Indeed, we're looking at some funding through the NumFocus small development grant to try and build, boost, and enhance this library to kind of stay here for the longer haul. And would really, really appreciate it if you get involved on GitHub issues or discussions through any of the major links that we've set up there. Next slide, please. So you can see all of our links that we have here. And you can download and use these as needed. We'll be sharing the slides in the link straight afterwards. Google pairs Patchscope paper presents generalization of multiple mechanistic methods, and so we have a more powerful approach. Next slide, please. So yeah, as mechanistic interpretability researchers, we encourage you to explore the capabilities of OBS, install the library with pip install, dive into the docs and start conducting your own experiments, clone the library and embark on a journey into the inner workings of large language models. Let OBS be your go-to tool for unlocking new insights and advancing your understanding of language model interpretability. Thank you very much.